All right. Can you hear me fine? Yeah. Hello, everybody. Thanks for coming. Today, I'm going to talk about the Rust SDK and what improvements we've made over the last year. So first, really quickly, is that guy. Hi, I'm Benjamin Bouvier. So I worked as a software engineer in the Rust team at Element. Prior to that, I worked on Rust and WebAssembly at different companies. And that was a big hobby of mine to write IRC bots. And at a previous company, they decided to switch from IRC to using Matrix. So I ported my bots that I written in JavaScript at the time to port them to using Rust. And that's how I started using the Rust SDK. And I wanted to experiment with having bots written in Rust and WebAssembly. So I made this funny project called Trinity. And that's how I got in touch with the Rust SDK team at Element and then got hired here. So the Rust SDK, what is it? It is an implementation of the client-server API. So it's a library that you can use so that you can actually write clients on your own in Rust. It's all open source under the Apache 2 license, so everybody can use it in their projects, and it's used in many projects, in fact. And it contains all the things that you would expect from a Matrix client in general, so everything from the login, logging out, like doing stuff with the settings, sending events, receiving events, listening to the events, and having specific event listeners that can react to events that have been sent to a room. Just so we are clear on the vocabulary, just in case, an event is every action that is happening in a room. Like when you're sending a message, it becomes an event. When you are adding a reaction, it is an event. When you join a room, it is an event. So this is like the handling of all these kind of events. And the very nice thing is that you get end-to-end encryption for free, in the sense that you don't have to worry about all the gory details of the encryption. There is a very complicated dance that you need to perform to have the proper encryption that involves Olm and Megolm, which are the implementation of the double ratchet algorithm, same as Signal in Matrix. And you don't have to worry about that. It's all handled by the SDK itself. All right, so some history of the project, because it's actually several projects all combined into one. In November 2025, people from the Rust and Matrix community decided to make Ruma for Rust Matrix, which is like a collection of data types representing the events of Matrix, as well as all the API endpoints, like the requests and the responses. And that is not only for the client-server API, but the server and server API as well. Jonas Platte was part of this project from the outset, I think, and he became an Element engineer later on. Meanwhile, in parallel, you also have Damir, who is the team lead at the Rust SDK team today at Element. He had a WeChat, which is basically a messaging client on Linux that you can use to connect to IRC, but it also had plugins so that you can connect to the Matrix network. And the plugin was written in Python at the time. And he decided to rewrite it in Rust for fun. But there was no SDK at that point. So he just decided to make one from scratch on his spare time. And from the beginning, he started to use Ruma because there is so much work done in that library that it didn't make sense to just reinvent the wheel for encoding all the events and all of that. And later on, well, Matrix is all about encryption, right? And so at the beginning, I suppose he was using libOlm, the C++ implementation of the encryption primitives of Matrix. And he decided to rewrite them in Rust as well. And that became the Vodosemac library that is entirely written in Rust right now. And the logo at the right, which is very cute, is the logo of Vodosemac. So really, the Rust SDK is the combination of using Ruma and Vodosemac for making an SDK. So you can't have a talk about Rust without having an evangelism slide like this one. So why did he decide to use Rust, and why do we like Rust in general? Well, it's pleasantly high level in the sense that you can have access to iterators and very high level constructs, but when they're compiled to very efficient code. as fast as C, or maybe like in 10% vicinity of C. And it's fast by default in the sense that most of the time you don't worry about performance because you get like very nice performance. And if that is not the case, since this is a compiled language, you can still have access to a native profiler to see what's going on and improve the performance of your application. Also has a small memory footprint in general in the sense that there is no garbage collection, no managed objects. All the memory allocations have to be explicit most of the time, and that makes it very powerful. Also, it's quite secure and memory safe. So there was a report by Google on Windows that 30% of their security exploits were caused by memory safety issues, I think, something like that, and 70%. Wow, yeah, well, that's even better for my case. And I suppose that this, while it's probably not true that all of these would have been avoided if using Rust, because there are still ways to escape the memory safety of Rust. Most of these would have been avoided by Rust, probably. There is like this notion of the ownership model, which is very not nice when you're starting to learn the language. Like, you will break your teeth on it for a while, but then at some point it makes you a better programmer in general. You understand better lifetime of your memory allocations and all of that. And it just gets rid of an entire class of memory safety bugs. And it's embedded in the language. Also, in general, Rust has an amazing tooling with the cargo tool, which is the all-in-one tool for like installing packages, compiling, testing, running benchmarks, fuzzing, doing all the things in just one tool. And it's extendable with also plugins if you need to. And there's a vibrant ecosystem of open source libraries on crates.io. And like usually when you look for something that you want to accomplish, there is a crate for that. It's also compatible with any languages. Well, you can call into and from any languages that speak the C ABI using the foreign function interface, FFI, here. So that makes it possible to call Rust from any other language that also uses, has a FFI that speaks the C ABI. And we'll get back to that because that's actually used the way we use it in the mobile apps. And the last thing that I love about Rust is that it's very empowering. It's like the compiler may be a bit tough sometimes, but it will always try to help you. It will hold you by your hand, and I love that. Like every time you have a compiler error, it will try to explain to you what is wrong and how you can get to fix it. And if you've done some C or C++ in the past, well, that's a different experience from using the C compilers. And it's getting better also on C. And also it is trying to make it very easy to write highly concurrent code. You don't have to worry about some low-level details. Sometimes it's a good thing, sometimes it's a bad thing, but it's trying to make it accessible to everybody to program highly concurrent and very performant programs. And yeah, let's get back to this. So on the right, you can see, so this was at the time in the Mozilla office. This is one of the most senior engineers at Mozilla in front of their standing desk doing some hacking. And there is a small panel on the wall, like maybe at 3 meters high or something like that, that reads, "Must be this tool to write multi-threaded code." And that's because writing multi-threaded code in C and C++ is very hard. You can have like lots of race conditions, data races in particular, and you need to be very acquainted with the memory model of your CPU to understand how to make sure that you don't have these kind of issues. And there is something that doesn't exist by default in Rust. You don't have data races. You can still have race conditions if the logic of your program is flawed, because there's no way to escape that. That's business logic. But you won't have that data races by default if you're using the high-level primitives of Rust, and it will complain about all the data races. So you can also, there's a escape hatch if you really need to manipulate atomics and low-level primitives of your CPU, and in that case, well, all bets are off. But by default, no data races. And this is so pleasant. After working like hours and hours debugging races in C++, this is really a breath of air. And also the ecosystem in general is going very strong on async code in general. It's embracing async for better or for worse. And that means that most of the code will be very concurrent by default, and it's pretty nice to make high performance software. Okay, so why the Rust SDK? So as I said, started as a personal project of an employee, and then, well, everybody got interested in the sense that, hey, this is actually nice. Programming language that can be called from other languages, single crypto stack, single code base for a client API. That's very sweet. Maybe we can avoid rewriting the crypto stack in many languages and have per platform issues and bugs that need to be fixed on each platform, each code base, each time. How about we use just a single code base for all the clients? And that was the idea behind the Rust SDK. So Element decided to adopt it for the new generation of Element apps, the ElementX apps. And as of today, it has high test coverage. I think we are around 84% of test coverage in the SDK itself. Some of the code is fuzzed, especially in the Vodose Max stack. We have also some basic benchmarking, and we can easily add benchmarks thanks to the cargo tooling. And it's also a central place where to add features and fix bugs, and not the other way around. So the old dream of Java may be accomplished with Rust today. All right, so who is using it? So mostly open source projects are using it. There is Fractal, which is a GNOME toolkit client available on Linux and probably other platforms too. You can see a screenshot on top right. There is a terminal UI client if you like Emacs or Vim stuff and just want to use your keyboard for more efficiency. There's the ElementX apps. Oh, there's also a newcomer who joined the ring recently, Robrix, which is desktop client using the Robrix toolkit for UI. So it's still very early, but it's quite promising. And yeah, so the ElementX apps that you will hear all about during this conference, as well as ElementR, the previous generation of apps, so basically Element and Element Web are using the crypto stack of the Rust SDK today in production. So it's not the entire SDK, but just the crypto stack are being used, and ElementR stands for Element Rust, I suppose. All right, so what do we mean when we say we're improving the foundation? Well, let's get a bit of perspective and think about it. What is a SDK for? What is a Matrix SDK for? It's really about, like, here's a code from my colleague Stefan, right there. So sending stuff kind of is our bread and butter. And if you extend that thinking just a bit, it's about sending stuff, doing interesting things with those events, and then receiving events, well, in any order. And in addition to that, you get encryption for free, and it's robust, right? So let's get to each of these parts one by one. Receiving events. As you heard, we have the synchronization protocol to receive events from the server. Your client needs to synchronize with the server, and that needs to be very efficient, otherwise you're going to wait a long time before you can do anything with your application. So at the beginning, there was the previous version of sync, which was not very efficient, so we introduced sliding sync, and the goal there was to have something that was near instant, independently of the size of your account. Even if you have thousands and thousands of rooms and conversations going at the same time, it must be instant. And that is based on like some UX heuristics, like we want to display something real quick on the screen. And it doesn't matter if we haven't loaded all of it right now, immediately. We just want to display something so that it feels fast as well. And then in the background, we can incrementally load batches of rooms from the room list. It has been a successful experiment, and we learned tons of insights about it. There was one thing that was done in the sliding sync, the original proposal, that was about ordering the rooms in the room list. And as Matthew alluded to earlier, it's actually not possible to do that if you have an encrypted room. And the reason is that you cannot distinguish an event that is not meaningful, like just adding a reaction, or it's not the best example because the reactions are actually not encrypted, but like somebody joined the room or left a room or just edited an event. For an encrypted room, that will appear as an event, and the server cannot look into it, otherwise it wouldn't be encrypted end-to-end in the first place, right? So the server would bump that room to the top of the list, even if the event itself is not quite meaningful. So that sorting of the rooms has to happen client-side instead. And by doing this, we could simplify the sliding sync a lot. And we had this new MSC for that, and much simpler, much better, and as of today, it's implemented in Synapse in like version 114, I think, and in the Rust SDK and fully supported. The Rust SDK still supports sliding sync, the original one, so that if you're using the proxy server written in Go, it still works. And if you're interested in that, you can go to Ivan's talk tomorrow at 10 a.m. Hi, Ivan, and you will get many more details and insight about that. All right, we received events. Now we would like to do some interesting things with those. So we introduced a new API called the event cache. And it's basically an observable store of events that come from any source, synchronization or any pagination if you're using slash messages or slash context to retrieve individual events. And we would like to also provide better APIs so that you have more processing of those individual events, because you want to make sense of them. Like, you're not only interested about an event, but also all the related events. So like the edits, reactions, read receipts, you get some kind of aggregate of those events. Right now, this store is baked in memory, and it's using what we think is an efficient memory representation, basically a linked list of arrays of events. And we think that this is well fit for relational database representation as well, because in the future we would like to persist those events on disk, so we will need to store these in SQLite. And that will also cause interesting problems, like we will need to deduplicate events based on their orderings. These are like some implementation details, but if you're a bit familiar with the endpoints, you know that the sync gives you an ordering of the events, but if you use another endpoint to do a backpagination, you will get another ordering of the events. So we need to reconcile them one way or another whenever that happens. And also, you can have gaps when you're doing a sync. For instance, if you're not running the ElementX application for a week or so, updates will accumulate, and so when you're restarting the app, you will have a gap of events that need to be backfilled. And so until you have some event that is common to the one you knew and the one you received from sync, you will have disconnected islands, disconnected timelines of those events. We need to be smart to reconcile them. OK. Now we also would like to send events. And we added a new API for that, that is the send queue. So we already had something for that, but we made it much better by fully rewriting it. And it's highly tested in isolation now. It's much more resilient to also async cancellation. If you try to send an event and abort it, it reacts much better now. So what you want for your high-level app is that you send an event and it immediately shows up in your timeline of event, right? You don't want to have to wait for the server to tell you, here's the event that you sent, because you know about it. So we have this concept of a local echo, and it's mandated in the spec that, well, it's recommended, I think, in the spec, that clients have these local echoes for the events that you are sending but are not quite sent yet. And the send queue is entirely observable, so you will get notifications about a new local echo has been added or edited or aborted. Because yes, you can actually edit them before they're sent, and even if they were being sent at the time you're trying to edit them, the SDK will do the right thing. And in that case, it will wait for the remote echo, so the server confirms that it's been sent, and then it will send an edit event, so that your intent is actually processed whatever it was. But sometimes it's not sent yet, so you can just edit it immediately in the database. Can also like send messages while you're offline, and we also have a smart dependency system in the sense that you can react to an event that's not been sent yet. So if you're acquainted with the spec, reaction, so putting an emoji, a thumb up emoji, for instance, on a message, requires to know what the event ID of the event you sent is. And we don't have that event ID because maybe we haven't sent the original event yet. So we have this dependency system that makes it so that you can send an event and then have dependent events like the reactions. And that paves the way for more local echoes like media uploads, where you first upload the media to the media repository and then send an event that represents the media with a link to the media repository itself. Also, if you quit and restart the app, since all the pending messages are saved on disk, you will not lose anything anymore. And the whole intent was also that if the network's stuttering, it's like you're in the metro, stuff like that, it will retry sending until it works a few times, and then if it doesn't work anymore, it will just block the sending for that room because there is no need to exhaust your battery life of your device by trying to send a message while you don't have network available. That means that a user of this API also has to set up some error listener to be able to react to that and then re-enable the network later, but we think that this is a valuable trade-off. Okay, so all this tech is boring. Let's talk a bit about literature right now. No, I'm just going to talk about encryption, and I would like to quote like the first line of the Anna Karenina book written by Leo Tolstoy. All happy families are like, each unhappy family is unhappy in its own way. And you're like, what's the point with that? What's the deal with that quote? Well, it's been generalized basically as every time you have a complex process with many substeps, if there is a single substep that fails, the entire process fails. And that's a bit what's going on with the encryption, and whenever that happens with encryption, you get the unable to decrypt message, the infamous UTD. And one answer to that would be to say, well, in that case, you need to build resilience into the system itself, right? But resilience is not something that you have. It's not a given. That's something that you learn over time and that you need to implement in your code base. Okay, so we started a big UTD hunt over the last year. And the first step was to be able to measure how many UTDs there were in the wild and to get a sense of how it evolved over time. So we made something that is a new small component, the UTD hook, that allows you to observe whenever you run into an unable to decrypt message. And that is fed to telemetry, and that can answer many useful questions like how does the ratio of UTDs versus non-UTDs evolve over time, and did a fix actually improve the situation massively, or was it just like an edge case that was encountered by a few users? So it was quite satisfying to have access to this telemetry because there was one particular bug fix, and I don't recall what it was for, but that lowered the ratio of like 5% down to 3% or something like that, which is kind of huge. And also it's able to deduplicate the UTDs, like, because again, if you close the app, restart the app, you may run into the same UTD on a subsequent synchronization, so we need to remember that this was a UTD. Also, you have transient UTDs because the protocol is such that you can receive the key for decrypting a message after you receive the message itself. So for a very short amount of time, the message will be marked as encrypted, and then later it will decrypt automatically. So we call that transient UTD or late decrypted, and we're also interested in having a reasonable idea of how many times that happens. All right, next step, obviously, is investigate and fix the UTDs. And this is like huge work done by the crypto team at Element, who also came in and went hack with us on the Rust SDK and Vodozemac stack. So it's pretty sweet. I would like to highlight some real-world examples of causes of UTDs that don't involve any crypto knowledge. Because you need to send the keys to decrypt your messages with Megalm, you need to know who is in the room, right? So this list of room members need to be accurate at any point in time. If it's not accurate, maybe you're not sending the keys to decrypt your message to somebody and they will run into utilities for your message. So we had a few issues with that, where we would like send a slash members request, which is the endpoint to receive like the room members. And for instance, in the past, it would fail once and never be retried. And in that case, well, you don't have an up-to-date list of room members, and the room members that you missed will run into utilities because of that. And then we have some fancy system where if you do multiple requests to slash members, since these requests can take a lot of time to process by the server, if you've tried it out on Matrix HQ, you know what I'm talking about. We will have an observer, like the second API call to slash members will wait for the first one to succeed, well, to finish. And before we had this assumption that this request always succeeded. So that if you had the second observer waiting for the first request to finish, and the first request was, for instance, aborted because we didn't really care anymore about the slash members request, the second observer will assume that it succeeded, and that's wrong again, and that leads to the same problem of the room list being out of sync. And now you're not sending the room keys to people in the room, leading to UTDs. If you're interested in this UTD hunt, you can go to Keegan's talk tomorrow at 2:30 p.m. And yeah, I think he's going to give some interesting stories back from the trenches as well. All right, you heard about invisible crypto as well. Basically, the idea is that you have some cryptographic proof that the sender message is who they claim they are. And to do that, it's a requirement on the clients themselves. And we need all the clients to agree that this is a good idea, in fact. So the idea is that you would mandate users to sign their devices with the cross-signing key. This cross-signing key is set up for the first device automatically by the Rust SDK. And then you get it to sign your other devices either by verifying them, or sharing the secrets or other means. And then if you're trying to send a message to a user who hasn't done that, it won't work. And if that person who hasn't done that tries to send a message, you will not see them. And for a transition period, we will show some insecure shield badge or something like that. But in the future, the idea is we would entirely ignore such a message coming from an insecure device. Again, if you're interested about that, there is a talk by Valère today at 2:15 for this subject. You heard about OIDC support, and yeah, so this was a long-standing project to move from the custom authentication system to OpenID Connect. You have more details at areweoidcyet.com. And it requires this additional service to run next alongside to your Synapse server or Matrix Home server. And it differs like the actual OIDC work to an actual OIDC provider, and then it's specialized for Matrix settings as well. It's written, like the service itself is written in Rust, so it had in particular a Rust client, which was very convenient for us to reuse in the Rust SDK itself. And it's fully supported. You can also have the login via QR code, as Matthew demonstrated. It's super nice. Just take a picture of a QR code, and you get logged in. In addition to that, you get access to the cross-signing key, so your device is automatically verified. And you get also access to the key backup key, which means that you can ask in the secret storage for the key backups of other rooms, so your new device can access the history of all the rooms that you joined on other devices, even for encrypted rooms. In the SDK, it's behind the experimental OIDC cargo feature. Maybe we'll get rid of it at some point because, well, Matrix 2.0 is right around the corner. Yeah. And I think that, oh yeah, there's going to be a talk about OIDC and mass by Quentin, but I don't recall when it is. Maybe today, maybe tomorrow. All right, in addition to all of these things, we also made high-level components. So there is the sync service, that basically manages synchronization. And if you want to benefit from all the UX practices that we've implemented in the ElementX apps, you can use that. You will get encryption for free. You will get the best performance because it automatically uses simplified sliding sync. And it's as easy as just like creating this weird data structure, the sync service, start it, and that's it. That's done. Then you can forget about it. It's running in the background for you. Also handling encryption. All right, and the other big component for UI clients that we made is the timeline, which will aggregate all related events into something that we call a timeline item, and you can get access to all the reactions, read receipts, entirely observable. You can get updates about I received a new event, or like a new timeline item, or like this timeline item at index 3 has been modified, or this one has been removed at index 2. And so you just have to handle an array, basically, of these timeline items in your client, which is pretty sweet. In terms of recent developments that we've made on this timeline API, you have the ability to focus on a particular event and automatically start back pagination and forward pagination. So that's basically after you've clicked a permalink, it will focus on that event and start to backfill in both directions. So you can actually like get to see the context of that event. And also, we have support for pinned event now. You can have a timeline just containing the pinned event, the same way you have that in ElementWeb, I think. Okay, so how do we use this in ElementX? So we are using the foreign function interface. In particular, there's a library made by Mozilla called Unify, or UniFFI, I'm not sure how you spell it out loud. And it generates binding automatically for you so that you can call into Rust and from the other language as well. And it can generate bindings for Swift, programming language used, modern programming language used on iOS, as well as Kotlin, which is also the modern programming language used on Android. It can also generate bindings for Python and Go, maybe more programming languages. I know that we're using the Go bindings for the crypto integration test suite, Complement Crypto, as well. And it requires some integration with the foreign language runtimes, which is something that we've helped contributing to over the last year. Ivan right there has contributed support for async code in those runtimes. So basically you have your functions on the Rust side that is marked as async, and you have the functions on the other side of the language boundary, like in Swift or Kotlin, that are also equivalently async. And it's all transparent. You don't have to deal about the details of an executor or anything like that. Sorry. Also, I think we contributed proc macro so that you can just annotate your function blocks and your types with export with UniFFI, something kind of like that, and it just works, which is kind of magic because before that you had to deal with COMC DSL, where you would redescribe all your types and functions, and it could get out of sync with the actual code itself, which was kind of bad. Okay, so here's a complete map, a bit disorienting, of all the things that I've talked about today. Basically start from the ElementX apps on the right, that starts a sync service. The sync service will manage sliding sync for you. Sliding sync will get events and forward them to the Helm machine, which is like the crypto object managing all the crypto, and the client for all the state events. And those events will then be forwarded to the event cache that will make better structure room updates that will be listened to by the timeline. And the timeline, well, is also like the view of your room, but also a way to send messages. So these messages are sent to the send queue. The send queue will forward the local echo back to the timeline. And all of this happens magically through the FFI layer. All right. So how do you do reactive programming? What is reactive programming? It's basically the ability to observe an object or a vector or any collection and see that it's changed over time. And so you would get an update. You can subscribe to it and get updates saying, here's the new value. So we made a contribution to the Rust ecosystem because the existing libraries were great, but not fit for our use case. So we made Able, and also able iamb, which is an extension for collections, because if you have an entire collection, a vector that has changed, you don't want to like send again the entire vector, because this would be inefficient in terms of memory. So you just say some things have been appended or removed or reset or changed, etc., etc. We also have extra querying facilities that make it so that if you wanted, you could implement SQL backend on top of these reactive things. Basically, you can batch changes in the same in a single batch. Then have also transactional updates so that you can start doing updates, and if anything fails, you cancel the entire update and don't forward the update to the listeners. Also filtering, sorting, which is used actually for the sorting on rooms in the room list. That's done client side. Okay, some fun stats. I looked at basically the last year of contribution. We had around 2,900 commits from 1,100 pull requests coming from 47 contributors. And I was interested in recurring contributors, actually. So 14 of them did more than 10 pull requests. And there is one external contributor, and by that I mean somebody external to Element, who actually made more than 10. And it's even more than 50 contributions that they made. And the core team is really 4 people, including one former Element employee, but the rest of us are still Element employees. So I want to highlight the work of this external contributor, Kevin Komai. Comes from the GNOME Fractal community. So Fractal is one of the UI clients that is using the Rust SDK. Basically, every time he needs something in the Rust SDK, he implements it. For instance, authenticated media was his work in the Rust SDK. He made it all work in Ruma and then implemented the remaining stuff in the Rust SDK. So his work is invaluable. Thank you a lot, Kevin. But thanks to all the contributors in general, if you're interested in exercising your Rust foo, we also have a few issues that are marked good first issues and help wanted, and we will be happy to mentor you and help you discover the code base and contribute so that your name can be on the slide next year, if you want. And also in general, we would like to thank all the people who are helping funding this work, in particular BWI, who funded the UTD hunt. This is our open source work. While there is free in free software, the work is not free by itself. So thank you for your contributions. And that's it. Thank you for your attention. Do we have time for questions?
Oh, absolutely. Do we have questions here?
I actually have 2 questions. Sorry, I had raised hand before, but I realized you're speaking loud. So one is with respect to this event queue that you talked about. So it basically is offline first kind of model, and then you are syncing those to the server. My question is, do you maintain a copy of everything that is not sent, or for like every messages? It's like the database inside the client. And why do I ask it? Because if you have everything on the client, then it's basically searchable. Because right now, at least on desktop and web, you can't search. On desktop you can, but on web you cannot. You cannot search the messages, which I think is quite important. So, I mean, that's my question. So is it just those which are not sent, which is like maintained, cached, and then sent, or everything?
So the answer is that we are saving everything. Well, that is the intent. Right now, we're saving only the messages that have not been sent yet. And in memory, we're saving everything, but that means having the clients alive. So in the future, we would like to persist on disk exactly for the use case that you highlighted, search. And actually, you don't need to have access to the events. Well, that's one way to implement it. We could just keep all the events and then figure out which have not been redacted or edited, or keep like the last edit or stuff like that, but it's probably a bit complicated. So the idea would be to just keep the index, like a search index, and so that we still have the ability to throw away the events, so that your storage doesn't blow up in terms of size either. Otherwise, that client would basically contain a copy of all the rooms you belong to, if you want to be able to search from the beginning. And maybe there are some interesting UX discussions about that, a trade-off in terms of, are we really trying to go back to the beginning of the room for a very active room like Matrix HQ? Maybe it doesn't make sense, and maybe since it's not encrypted, we can just use the server API for that instead. But for regular encrypted room, we can probably do something like that, and we're confident that it should give good results. There's actually an implementation in Rust of a search engine called Chat, I think, that has been used experimentally in hydrogen in the past, and that was doing that. So we can probably plug it in the Rust SDK when the time has come.
So does that make the copy in the browser itself, and then?
Sorry?
So it makes a copy in the browser itself and then searches it. All right. My next question is with respect to, so does it, the whole SDK compiles to WASM so that it can be used on web? Or it's just part of them? So you were talking about this functions that other API was FFI.
Oh, yeah.
So is it available for the whole SDK, or is this part of it?
So it's complicated. Basically, so we have integration with UniFFI for things that are used in the ElementX apps themselves. And we don't have a JavaScript WebAssembly backend for UniFFI. So one way to go with compiling that to the web would require to make a backend for Unify in the first place so that it can compile to JavaScript and WASM. But an alternative path that we've taken for the crypto stack, in fact, is using WASM binding. And this is how we make custom bindings. And it's a bit simpler because JavaScript is also some weird stuff that is quite different from those other languages. So it's probably an open question. Element Web is not going to disappear anytime soon. And the SDK is there, not quite yet. I think the Matrix SDK crate itself can be compiled to WASM. Matrix SDK UI relies on some system APIs that don't compile to WASM, and since we didn't have a use case, we didn't bother doing that. Although there is a PR open as a draft from somebody from the community to make it compile to WASM by probably removing some features. So it will be possible, I think, with some extra work, but it's not priority right now.
Because at least there's this Matrix React SDK and then JS SDK. And then you have the Rust SDK, which is kind of... We need a microphone on that. Together. Yeah. So essentially you have this Matrix React SDK and JS SDK. And then you have the Rust SDK, which is kind of doing everything together. And then, so it's like two tracks. So
right.
Wondering.
These are two different tracks, really, and we can talk about that after if you want. But I think that we're still a bit of long ways until we can use the entire Rust SDK in a browser.
Sure.
Thanks.
I've got a mic. Hi, Benjamin. Thanks for the nice talk. You answered quite a few questions I had, so that's great. Also, thanks for mentioning our new client, Robrix. I also just wanted to mention as a selfish plug, it does support mobile too, natively,
nice.
in Rust. Yeah, not just desktop. And hopefully Open Harmony as well, a new OS next year. I had a question about the event cache. I noticed that on the to-do agenda was supporting persistence to disk. When is that planned? And if it's not anytime soon, what can I do as like a workaround to persist my local copy of events to disk so I can have like an offline mode for the client?
That's a great question. So it is planned for soon-ish. I will use the strategy of not giving any deadline to not give promises, but this is something that we would like to work on because this will be a huge improvement in terms of UX. Like if you're offline right now, you may see a few events, but because we have a transient implementation of a cache, but it doesn't contain a lot of events and it's very not smart. So we would like to improve it, but so that's something we would like to work on soon. That's the first part. What you can do in the meanwhile is probably store your events by yourself by adding a listener on like the most generic Ruma type. That might be any sync timeline event or something like that. And then you have a way to inject events into the event cache.
Okay, that's the like add initial events or something. But
Yes.
so when I looked at that, I think it was like slated for removal. Is that going
Yep.
to happen? It's not going to be removed until you have
Exactly, yeah.
support for native.
Yeah, it's the
SDK.
transient solution until we have
Okay.
proper storage for the event cache, indeed.
Okay, so those event types should be serializable to disk now, so I can store them in my own client implementation and then inject them back into the event cache when I restart the app on a subsequent execution?
I think that should work, yes. And what you're receiving from Ruma is the JSON encoded version, so you can save that to disk and not have to worry about custom events in particular. Custom events, you're not aware of their format, so you can't deserialize them.
Okay, so it should be saved much earlier on in the,
Yeah.
the decoding procedure or whatnot. Okay, thanks.
Sure. Any other question?
Yeah.
Yeah.
Hi.
Hi.
Thanks for the talk. It was an excellent talk. Can it be used for building application services?
That's a great question. We removed the support for that 6 months ago, I think.
Oh my God.
Sorry about that. That's because it was not well maintained, and instead of making the promise of having an API that's not well maintained, we'd say to the people who were interested in it, feel free to fork the SDK or either make it a separate component that can plug in into the SDK or rely on the SDK, but we couldn't bear the maintenance cost of that. So if you're using Ruma, you have access to all the events that are related and API endpoints, so you can probably build something on top of that. And there might be some project already existing doing that, so good luck.
Thanks.
Okay. We had a couple of questions online too. I think I will fit in one very short to answer one, and that is Marl asks, where can I find the Golang bindings to the SDK?
Sorry,
are there Golang bindings?
Go bindings, probably somewhere. So if I would look at the source of the complement crypto test suite, that would be the right place to look for how the bindings are generated. I have no more insights about that.
Okay, thank you. I think there's some more technical questions where perhaps you can find some time to look at the chat
Sure.
Afterwards. We are, well, maybe you have already heard the bells ringing outside. It is 12 o'clock here. Now we are going to have a lunch break of 90 minutes. And we will be back here at 1:30 o'clock with Danielle talking about from protocol to product, taking Matrix into a typical workplace environment.
All right.
Thank you.
Thank you.